All right, welcome to grade 11 physical science. And we are going to look at a very, very important section here. Why is this section important? There's a lot of things that's going to ride on this in grade 11 and in grade 12. In fact, physics rests on this. We started this in grade 10 when we're talking about the two different types of quantities that we have. So I'm going to revise that quickly and then jump into what we have for today. So we need to first understand quantities. So let's quickly revise. Quantities. There are two types of quantities in physics. All right. There is what you have as scalar quantity. I'm sure you remember this, guys. A physical quantity that has magnitude only. Can anybody give me examples? Anybody? What you remember from grade 10? Quickly. Beautiful. Thank you. Speed. Temperature. Beautiful. Thank you. Let's see, I think one more example came in. Oh, still speed. Lovely. What about time? Mass. All of these are examples, all right, of scalar. You only talk about the values. Speed, 2 meters per second. Temperature, 25 degrees Celsius. Time, 20 seconds. Mass, 5 kg. All right, so all of these are just numbers that we use in measuring things. Now, number 2, vector quantity, which is our main focus now, will be a physical quantity that has both, let's put the word both there, magnitude and direction. All right. Examples? Lovely. I love what you are giving me. It's like you were waiting. Acceleration. Who gave me another example there? There was velocity. I remember. Lovely. Somebody says displacement. Beautiful. Somebody says force. Great. In fact, somebody mentioned the word gravity, which is a force, by the way. Now, every time we talk about all of this, there is direction involved. We're either going to say left, right, down. Is that okay? Beautiful. Lovely examples. Now, our focus in grade 11 would be to use force. Is that okay? Force. Now, we are going to start by talking about the representation of a vector quantity. So this is grade 10, and we're good. We pass the test quickly. How do we represent a vector quantity? Representation of a vector quantity. Representation of a vector quantity. We use an arrow to represent vector quantities. So you have an arrow there. This particular part, which is the tail, represents the magnitude, which is the size. And the arrowhead represents the direction. So we talk about magnitude and direction. So this is how we represent a vector quantity. A vector quantity. Magnitude and direction. So we're going to quickly look at a few examples which we did in grade 10. All right, just to show you something. If I tell you a force of 5 Newton east and a force of 7 newtons east, what's going to be the difference between the two? Let's represent that. If that's 5, we don't really have to measure. We're not doing scale this time. All right, that's 5 newtons and 7 newtons. Now you can clearly see that the 7 is longer than the 5 because 7 as a numerical value is bigger than 5. Guys, can I get your thumbs up to see if you are still okay? There's a hand raised. Teboko, hand raised. Guys, we raise our hand if there is a question or you want to call my attention to something. But if I want your thumbs up, just check. You check the reactions there. Give me a thumbs up. And if you are lost, you can give me a thumbs down. If you raise your hand, probably you have a question. Awesome. Tendani, is it Tendani or Tondani? I see a thumbs down. Tondani? Tendani, I'm not sure. You need to respond very fast. So, sir, we don't add. We are not there yet. Can we take it one step after the other? We are looking at vectors. These are examples of vectors. Do you understand what I have said so far? Beautiful. All right. So these are examples of vectors, guys. We have 5 newtons, we have 7 newtons, we have 10, we have different directions. If I tell you 7 newtons west, it means that in length, it should be equal to the other 7 one. But in direction, it should be different. I am emphasizing that the length shows the magnitude. The length shows the magnitude. All right. Now we are going to quickly look at the addition and subtraction of vectors. Addition and subtraction of vectors. One second, just trying to quickly assist someone who's trying to log in. One second. Just a moment, guys. Okay, quickly. Let's look at this. Resultant vector. What is a resultant vector? We're going to start by defining a resultant vector. Alright, so we're going to define a resultant vector, alright, as the vector sum. A vector sum of two or more vectors. Please listen carefully. A resultant vector is a vector sum of two or more vectors. That is, a single vector that has the same effect as two or more vectors. A resultant vector is a vector sum of two or more vectors. So you can have two or more vectors. When you add them together, we are going to then talk about a resultant vector. Okay, we are going to start with collinear vectors. Is that okay? Collinear. The word co means together. Linear means straight line. Collinear vectors. Let's start with that. Collinear vectors. So we are talking about vectors on a straight line. How do we find the resultant vector of collinear vectors? It doesn't matter whether there are 2, 3, 4. It really doesn't matter. We're just looking at how to add them together and subtract. So we're looking at collinear. It could be vertical. It could be horizontal. So let's put here either vertical or horizontal. Note, always take and state direction before adding. Basically, guys, we add vectors. Example. Number 1. What is the resultant vector of a 2 Newton east and a 4 Newton west force? Since we says force is an example, what is the resultant vector of a 2 Newton east and a 4 Newton west? Let's start by drawing quickly. 2 Newton east. East is that way. 4 Newtons west. All right. Now we are going to solve this together by calculation and then by drawing. My note says take and state direction. Is that okay? So I would start by saying, let's take east as positive. Now we are going to write, since you're dealing with force, we are going to have F resultant, F res, as equal to F1 plus F2. We have two forces. Our F1 is 2 Newton east. Our F2 is 4 Newton west. We did this in grade 10. So our F resultant, therefore, will be, what is our F1? Positive 2. Because it is 2 Newtons to the east. And we said east is positive. Plus, what are we going to have? Negative 4. Right? Why negative? Because it's to the west. And we chose east as positive. So what's our answer? Negative 2 Newton. But we don't leave our answer as negative.
So you said we will take east as positive.
Yes.
So is it you who decides on this direction?
All right, that's a question. Who decides on the direction? You. Another learner can take east as negative. We are going to get the same answer. All right. So what's our answer here? 2 Newtons. But what is that negative? What does that negative mean? West. Because we chose east as positive. And we are done there. You have to change the negative. All right? Don't leave your answer as the negative tells you that there's a direction involved. In physics, plus and minus represent directions when you are dealing with vector quantities. So please, don't leave your answer as just negative 2 or even 2. You must write the direction, except the examiner wants you to just write the magnitude. But if they want the force, because it's a vector quantity, you must write both magnitude and direction. Are we okay? So this is an example of linear. Why linear? It's in a straight line. Is that okay? Now, in grade 11, we are going to move into 2 dimensions. That's where the work is. So I'm trying to warm you up quickly. All right, thank you guys. Thank you for the thumbs up. Beautiful, beautiful. Beautiful. Let's look at how to use a diagram. Let's see something here quickly. Let's see how to use a diagram. Let's see how to use, or before we use a diagram, let's try something. Before we use a diagram, let's try something. And then we'll look at the diagram to do both this is one dimension. One dimension means either linear, vertical, or horizontal. Let's see. If I have this, 4 Newtons north and 6 Newtons north. Do you want to quickly give me the resultant force? What are you doing? With a calculator? 4 and 6? Never. Let's exercise the mind. All right. So, since it's one dimension, it's either north or south. So let's take north. Please, this is very important that you write your direction. So F1 will be positive 4n. F2 will also be what? Positive what? 6n. What is F resultant? F1 plus F2. 4 plus 6. What's your answer? My answer is positive, right? But if you leave your answer like this, you lose marks. It must be 10 newtons north. Because force is a vector what? Quantity. Let's try another one. 3 newtons north and 6 newton south. What will your answer be? Type your answers for me. Oh, thank you for those answers you gave me earlier on. Thank you, guys. Thank you, Divine, Noran. Awesome. Samika, lovely. Dinell, good. Ladin, you guys are great. Okay, I'm seeing new answers coming in. All right, these are just basic things, guys. So what do we take? Direction, quickly. I know most of you took north as positive. I want to change. I want to say take north as negative. We must get the same answer. That's what we are trying to say. All right? Take north as negative. Okay, let's see what's going to happen. F1 will be what? Negative 3. Does that make sense? Because it's north. And I'm saying my north is negative. What is F2? That means if north is negative, south has to be positive. So what are we going to have? Positive what? 6 newtons. Now what is our F resultant? F1 plus F2 negative 3 plus 6. What's our answer? Positive what? 3. Now, which one is positive? South. Because we said north is negative. So therefore, my F resultant is what? 3 newtons what? Whichever direction you take. Kyle, why do we have 3 newtons north? Oh, okay, all right. So this is what I'm going to tell you. F resultant will always be in the direction of the bigger force. F resultant, please, that's very important, will always be in the direction of the bigger force. Is there someone trying to call my attention? Teboko says, do we always declare a positive direction in physics, or we can also choose a direction to be negative? You can choose a direction to be negative. You can. All right? You can. You can. It's just a matter of interpretation. So if I say north is negative, it means that south is then positive. But you can. All right, let's move on quickly, guys. I want us to move on quickly. In grade 10, we did something called tail to tail and tail to head. So you guys remember that? Where you join vectors. Okay. let's look at an example. Resultant vector in diagram. Resultant vector in diagram. All right. Tail to head. This is more appropriate if we are using one dimension. Number 1, 2 newtons east and 3 newton, let's say east. When we say tail to head, what are we doing? You connect the tail of one to the head of the other. So my 2 newtons quickly would be that. 3 newtons. You start from where that one ended. That's what we mean by tail to head. That's the tail. That's the head. Tail, that's where that name comes from. The tail is connected to the head, or the head connected to the tail. And then what do we have here? That's the head, right? Then, to draw my vector, it has to be from the open tail to the open head. Does that make sense? This tail is open, it's not connected. This head is open, it's not connected. That is going to be my resultant. And if you notice, 2 newtons, 3 newtons, in total, 5 newtons. Does that make sense? This is grade 10. We did all of this in grade 10. Are we okay? All right. Just want to run quickly. I'm eager to get to the grade 11 part. Eager to get to the grade 11 part. Let's see something. If I have 2 newton east and 3 newtons west. Okay, I'll give you a moment to finish writing. Try to do that for me. Let's see. Before we go to a Cartesian plane, we're moving to a Cartesian plane just now, guys. Try to do that from grade 10, your grade 10 knowledge, and then we mark. I have 2 newtons to the east and 3 newtons to the west. What would you do? All right? In this case, it is easier to work with tail to tail. When they are in opposite direction, it is easier to work with what? Tail to tail. When I say tail to tail, it means the tails are now connected. All right? The tails are now connected. So what are we going to have? 2 newtons east will go to the right. What about 3 newtons west? To go to the left. But I am going to connect. Does that make sense to you? 3 newtons and 2 newtons. Let's put a dot there. It's always good to use that dot to start. Now, where will our resultant be? The resultant is always in the direction of the bigger force. Which one is the bigger force? 3 newtons. So it has to go where? West. But what's going to be the value? They are in opposite direction. What's the answer? 1. Because one is positive, the other one is negative. If you add together, basically you are subtracting. Positive 3 minus 2. What's your answer? 1. And in which direction? Lovely. So I'll go start from the beginning and then draw. 1 Newton. Divine, talk to me. So I would like to ask, is there a chance that they would ask us to do an example with head to tail rather than tail to head? It's the same language, Divine. All right? It's the same language. Tail to head, head to tail. It just means that the tail is connected to the head or the head connected to the tail. That's all. So tail to head to tail, we're talking about the same thing. Are we okay there? Let me know if you're okay. Oratile. Sir, can you please re-explain again? Okay, Oratile, I'll do that. Yes, Luke?
Yes, I have a question. So, in this case, do we choose or they already choose for us? Like which one is positive?
Examiner would not tell you which one is positive. You choose what is positive. Except they want to restrict you. But please, choose what is positive to you and what is negative. What will be wrong is for me to say 3 newtons west. Then I draw this. That's not west. That's east. So, let's check. Let's check something quickly. Elena decides to choose east as positive. What will my F resultant be? Which one is east? 2, right? So F1 plus F2. Since east is positive, positive 2 plus west is negative. What's your answer? Negative 1. Now, which one is negative? We said east is positive. So, what is negative? West. There we go. Elena decides to choose west as positive. F resultant equals to F1 plus F2. If west is positive, east has to be what? So, what is our F1? Negative 2. Because that's east. Plus, what is F2? Positive 3. What's your answer? 1 Newton. But this answer is positive, right? And we said west is. So what's your answer? 1 Newtons. Same answer. All right, okay. I've got a question. Is the 1 Newton the remainder of 3 Newton after subtracting 2 Newton? Or the other way around? Going to answer that quickly. Just waiting for the guys here to finish writing. All right, are we good? So the direction really doesn't matter now when you choose, but you must keep that direction until you get a final answer. Okay. All right, let's quickly get back to that question. Divine, I was asking if we could try 2 examples with tail to head method. All right. I'm going to work out different scenarios. All right. Now, please listen. Look at my diagram in number 2. Please, I want you to see this. It says 2 Newton east and 3 Newtons west. And these forces are acting at a point. All right? They act. I'm putting this at this point. Is that okay? Acting at that point. Now, if I draw my diagram like this, please, guys, I want us to check my representations. If I draw my diagram like this, then the 1 Newton would be to the left, and I am starting at that point. Watch this, please. If I have my 3 Newtons here, okay? If I have my 3 Newtons at that point, and then I have it was 2 Newtons it was 3 Newtons what? 3 Newtons west, and 2 Newtons what? East, okay? 3 Newtons to the west, and my what? 2 Newtons to the east. All right, please watch this. Now, do you notice there is somewhere remaining? Let me use a green thing to draw this. A boundary. I'm drawing my forces in a boundary there. Does that make sense? Now, it means the remaining part then becomes my resultant. And in which direction will that be? That would be to the left. Why? Because the resultant is always in the direction of the greater force. Does that make sense, guys? Please, our representations are very important. Now, you would see that the 1 is the remaining part of the 3, but I have enclosed my diagram in the green line boundary. Does that make sense? My forces are enclosed in the green line boundary. So out of 3, I am removing 2. The remaining 1 is my resultant. And the resultant will be in the direction of the what? The bigger force. Which force is bigger? 3. Hence, it's in that what? Direction. Are we okay there? All right. Guys, we'll look at more examples as we go on, but I'm sure your answers are getting in place. All right. We don't really draw head to head. I'll show you where the head and head will meet shortly. We're going to go into 2 dimensions. All of this is grade 10, but I need part of this grade 10 for us to move to grade 11. Okay, so guys, as we do grade 11, we're going to come back to grade 10. Is that okay? We're going to come back to grade 10. Let me see something. Wait, let's see something. Let's play around with the question. What do you think? Let me check something with you. What do you think is the answer to this question? I have moved from, this is no longer linear now, right? But I want to see what your take would be. The diagram represents 4 vectors, Q, R, S, and T. Which one of the vectors is the resultant of the other 3? It means there are 3 forces here, and the 4th one is a resultant of the other 3. Let me give you 2 minutes. Please look at the arrows very well. So, Pamani, we don't draw head to head. And you would see carefully. A, B, C, D. Eighteen more seconds. Oh, 18 seconds just flew like that. So what's your answer? Let me go check your answers now. Yes, the guy's here. What's your answer? Okay, let me see. I'm going to go around now quickly. A lot of people are saying R. Okay. Guys, it means you guys are not, you guys don't know how to answer a question. R is wrong. The options are A, B, C, D. The options are A, B, C, D. So I don't understand where you guys are getting R from. It says A, B, C, D. You guys are telling me R, S, T. Are those options? Alright, guys. Like, really now? You guys are also laughing at yourselves, right? Good. R, S, T. No. A, B, C, D. Okay, let's check. if you notice, this is what I would have done. I have a head here, right? And this head is connected to the tail. So do you see tail to head to tail? Same story. Head. Oh, connected to the tail. Oh, so that means S is connected to T. Using which method? The tail to head or the head to tail language. What do you have here? Ah, there's another head here. Oh, there's a tail here. Oh, I mentioned something earlier. The open tail, where it starts from, will be the tail. And the open head, let me do something for you. Let's see if this is going to make sense. Let's do this. So what do you notice? It's a link. It's continuing. Tail to head, then we connect another one. Tail to head, then we connect another one. What do you notice? There's an open tail, and there's an open what? Head. And that becomes my resultant. Did that make sense, everybody? So my correct answer is what? It's not R. Option is what? B. Hey. Science learners and English. Okay. Correct option is B. We're good. Thank you so much, guys. Denzel, are we okay? Akona, I see your answer is A. Okay, let me check something. Let's check A, because A is Q. Why is Q wrong? Let's check again. Don't let's condemn answers. Let's check something. Okay, check this. Do you notice that this is, let me clean this. If you say that, oh, now I cleaned what I wanted to show. Just to be able to assist everyone. All right, there we go. You notice what I have left? Head and head. And head will not be a vector. It has to be tail and head. All right? Teboho. So a vector should have what? Tail and head. This one gives me what? A head and another head. Are we okay there? All right. So a vector must have a tail and a head. All right. Guys, I hope that makes sense. I've got a mic on. All right, Teboho, yes. So a resultant must be drawn from tail to head. All right, good. Let's quickly do 2 dimensions now. Please, I need you here. 2 dimensions. Please, I need your attention. Pay double attention as we go into 2 dimension. Nice rhymes. Now, when I say 2 dimensions, it means one is going vertically and the other one is going where? Horizontally. So I'm just trying to allow someone in. Okay. All right, guys, let's move quickly. I need to run. There's a lot of activities to do on this. This is now the grade 11 part. Please, I need your mathematics. All right. 2 dimensions. So we are talking about a combination of vertical and horizontal. I have somebody's mic on. Steps. 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 Number 1. Combine all linear vectors. Combine all linear vectors. When I say linear, it means that is combine all horizontal to have a single horizontal vector. And do the same for vertical. This will give you only 2 vectors left. That is 1 vertical and 1 horizontal that are perpendicular, very key, to each other. Joined, both joined by the tail. So we are looking at something tail to tail now. Both joined by the tail. This is why we had to quickly go through that grade 10 part. I hope what I'm saying makes sense. We good, guys? Can we continue? Awesome. So combine all linear vectors, which means the ones that are horizontal, combine them until you have 1 horizontal. The ones that are vertical, combine them until you have what? 1 vertical. All the horizontals, if they are in the same direction, you add. If they are in opposite direction, what do? You subtract. You get 1 horizontal, 1 vertical. That's grade 10 now. Is that fine? So at the end of the day, you are left with something that looks like this. 1 vertical, 1 horizontal that are connected at 90 degrees. Perpendicular to each other. Now step 2. Okay, let's draw that diagram again. So you have F horizontal, which is a combination of all the horizontal ones, and you have what? F vertical. Guys, once you see the word vertical, 90 degrees is in place. All right? 90 degrees. Now, how do you find your half resultant here? Please watch this. Give you a note here. We use a parallelogram of forces This is done by drawing, I'm going to use a word that we used in grade 10, equal forces or vectors. I'm going to ask you to define equal forces or vectors for me now. All right. To complete a parallelogram, such that the tails are joined and the heads are joined. Draw your F resultant tail from the joint tail and head from the joint head. I'll explain this note. Let's be fast in writing. Okay. Are we okay, guys? I want to explain. So, this is what we do. That is that. That is that. Is that fine? Now we complete this diagram by using dotted lines. We draw equal forces. And equal forces are defined as forces that have the same magnitude and are in the same direction. Equal. They have the same magnitude and they have the same what? Direction. So this is what I'm going to do. Check. I'm going to complete a parallelogram. You see, I am drawing a force that is equal to this one. Let's call this is F1. I am drawing a force that is equal to it. Why are they equal? Same magnitude, same direction. So what do we then do? Can we draw the other one? Ta 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 ta. Tail to head. What do you notice? Do you notice that I now have the tails in one place and I have the heads in one place? And your resultant must have what? Tail and head. So what do? I take that now and draw from the tail. That's the tail and that's the head. And this is my F what? Resultant. Does that make sense? Tail would come from the tail. Head would come from the head. So the tails are here and the heads are there. And one thing you must not forget, these forces are what? Perpendicular to each other. So if this is 90 degrees, what is that? Do you notice that gives you a right angle what? Triangle. Now we have a right angled triangle. We calculate the magnitude of F resultant by using the theorem of Pythagoras. F resultant squared equals to F1 squared plus F2 squared. We all still remember. That's why I said, please bring in your maths. Yes, Teboho, I have a parallelogram. That's how we call it, a parallelogram of forces. Guys, are we okay? Because I need us to go to, we're going to get to inclined forces today. So we need to increase the pace. I just have people trying to log in and I don't know what's wrong with their phones. All right. Now, we also know that a force must have what? Magnitude and direction. I want us to do both at the same time. Magnitude and what? Direction. Are you with me, guys? A force must have both magnitude and direction. And we are going to use our Cartesian plane to draw all of this. All right. Use our Cartesian plane to do all of this. But let's see. Let's calculate resultant first before I go to the angle. Let's calculate resultant first before I go to the angles. Guys, quickly answer this multiple choice. Let's see. Let's test you now. Yeah, you should be able to answer this too. I'll give you 4 minutes. Let's make it snappy. 4 minutes. Take your time. There are 2 questions there, 2 minutes each. Guys, let's not play with the presentation. Amanda has now taken over the presentation. Amanda, are you the one teaching? All right, we should be done. We should be done. Let's mark. Let's mark together. Two vectors, two equal vectors, P and negative P, act at a common point. The angle between the two vectors is, what's your first answer? They said two equal vectors, P and negative P. It means they are acting. Remember we said one is positive, one is what? Because it's plus and minus. Check. If I choose right as positive, that's P. Positive P. Where should negative P be? To the left. What's the angle there? Simple maths. Answer is C, 180 degrees. Even if I choose to go up, positive P and negative P, because they are in opposite what? Directions. What's the angle between them? 180. So the correct option is what? C. Guys, the signs are important. Number 2, 4 vectors act on a point. Now we have what? Vertical and horizontal. The magnitude of the resultant or net, I was going to mention net as we go on, in the horizontal and vertical direction. Okay, let's look at the fx, horizontal. What do you notice? One is to the right, other one is to the left. Can we choose right as positive? Left would be negative. So let's add. What are we going to get? 5. So our answer cannot be this. It cannot be that. It's either B or C, or B or D. So those of you that chose A and C, already you are wrong. Let's look at the vertical. In which direction are they? They are both in the same what? So let's choose upward as positive. This one is positive, this one is positive. Let's add them together. What do we have? 25. Oh, so it's 5 and 25. Done. Answer is B. Simple physics. Guys, is it making sense? Simple things, you know? Let me know if we are good, guys. All right, guys. I am going to use number 2 to show you how to get resultant force. So, guys, we're going to use number 2 now. Okay. We're going to use question 2. I'm going to be very fast now on this because I want to get to how to resolve component of forces today. So I'm using number 2 now, and we want to quickly calculate the resultant force. How to calculate the resultant force. Then I think I have one question on this. All right, let's walk through from here. Everybody, please listen carefully. I'm using number 2. I wanted to cut something out, but it's not working. All right. So we want to look for the resultant force in question 1.2. What do you notice? There are two forces pointing up, right? Good. It means that our Fy is 25 newtons. Does that make sense?
Yes.
Do you guys still remember how we got the 25? You remember how we got the 25, right?
Yes.
Good. Then our horizontal, where will it be? Oh, by the way, let's say this one is upwards. Is that fine with you there? What about Fx? Which one is longer? The one on the right, the 20.
Yes.
So our Fx should be what? F newtons in which directions? East. Everybody okay? So what do we have? We're going to have something that looks like this. What is this? 5 newtons. What is that? 25 newtons. How do we get our resultant? We start by drawing what? A parallelogram. Make sense? And the head is that. The head is that. So what are we going to have now? We're going to have our resultant. F what? Resultant. Now, do you notice that this is 90 degrees? And this one is also what? 25 newtons. This gives us what you call a right angle triangle. How do we find resultant? The theorem of Pythagoras. Because that's what we use when we have a right angle what? Triangle. So I'm using this. F resultant squared equals to what? F1 squared plus F2 squared. What is F1? Whichever one. Or let's say Fx. Let me use x and y. Fx squared, Fy squared. What is this? 5 squared plus 25 squared. What do? We use our calculator, right? F rest squared. That is 25 plus 625. That should give us what? 650. 650. But is that our answer? No. There's a squared there. What do we do to that squared? We find the square root. Guys, are we okay? We find the square root. So what is this? F rest would be square root of what? 650. And what's your answer? 25, comma? What's your answer? Yes, in decimal. 25, comma? 50. Okay, don't give me a rounded up answer yet. 25, 49, 4950, blah, blah, blah. All right. So, 25, 49, and the other number is bigger than 5, right?
Yes.
So, we round up to be what? 50 newtons. Guys, I'm taking it step by step. Are you okay with how to calculate the magnitude? We have not started about the direction yet. We are only dealing with the magnitude. Because there must be a direction. Yes?
Is it possible if they can give you the F resultant, then you have to manipulate F swap?
Absolutely. They can give you F resultant. And then you have to calculate Fx or Fy. Man, this is math and physics. Everything is possible. Tebo, can we take it step by step, please? We are dealing with the magnitude. I just mentioned that right now, that we are focusing first on the magnitude. Guys, are we okay on how to calculate the magnitude? We were going to go now into how to get the direction. But first, we are dealing with the magnitude. Okay, let me see if I can give you a question. We deal with the magnitude first, and then you calculate the direction. All right, I thought I had something here. Okay, it's fine. I'll create one for you. Let me see. I thought I had something. Let me quickly create one. Then when I do direction, you'll also do directions. Quickly, everybody, let's get this. So I'm using this as a Cartesian plane. 10 newtons, 2 newtons, 3 newtons, 8 newtons. Calculate the magnitude, which means I'm not focused on direction yet, all right, of the resultant vector. Let's move quickly, as quickly as possible. 4 minutes, I think that should be okay for us. 5 maximum. After this, then we go to direction. Be finishing. All right. Okay, so what do? We combine the verticals, right? So we'll say F. Okay, let's start by saying upward as positive. So Fy will be what? Positive 10 plus negative 2. Do we agree? Which gives us what? Positive what? 8. What do we have? Fx. Let's choose right as positive. Fx would be what? My right is now positive. What would I have? Positive 3 plus negative 8. What's my answer? Negative 5. This one tells me 8 newtons up. This one tells me 5 newtons what? Left. So your diagram should look like this. Sorry. What is this? 5 newtons, 8 newtons. Did you get that correct? Guys, now from here, what do? We can complete. Guys, no matter the number of forces you have, you must first combine until you get one vertical, one horizontal. That's why we did the linear ones first. All right. This one is this way, that one is that way. Then only I can now do that, which gives me my resultant what? There. So automatically this is now what? 8. F resultant squared is equal to Fx squared plus Fy squared. What is your Fx? 5 plus 8 squared. And then you find the square root. We are done. Calculator quickly. The square root of 25 plus 64. 9,43. We are done there. This is only the magnitude. At Nkosi, I always prefer that. Write down the direction, please. It tells the examiner to follow what you are doing. Are we okay? All right. Guys, are we okay? Combine first until you have one vertical and one what? Horizontal. All right. Now, how do we calculate or determine the direction? So we are all okay now with magnitude, guys. Please. The note is right there to follow. That's why I broke it down into 2 pieces. Number 1, combine. Step 2, Pythagoras. Now, we want to deal with the direction. how do we get the direction? So now we are dealing with what? Direction of resultant vector in 2 dimensions. All right. The direction will be measured as an angle in a trigonometry function. The angle is usually measured from the reference, my spelling of reference axis. All right? And this is usually the positive x-axis measured anti-clockwise. Measured anti-clockwise. Now we are dealing with how to measure the direction. However, there are various ways of representing this. All right, there are various ways, and I would prefer that we even state the directions. There's a lot of different representations, and I will show you what I do. I'll show you how I do mine. So, for example, let's have this. And now, just what we've done earlier on. We now have our resultant. So F resultant, Fx, Fy. The direction will be measured as an angle. Ideally, we start from the x-axis because that's how we were doing trigonometry. All right? In grade 10. We start from the positive x and measure anti-clockwise. That's the angle there. All right? This is the angle. Now, since this is a right angle triangle, I don't know if you guys still remember SOHCAHTOA, where sine theta is opposite over hypotenuse, cos theta is adjacent over hypotenuse, tan theta is opposite over adjacent. Now watch this. If this is my angle theta, it means that this side becomes what? Opposite. Right? And this side becomes what? Adjacent. It's just strict now, guys. You can use any, but we normally just use this one. Let's stick to this one so that we don't confuse ourselves. I have opposite and I have what? Adjacent. Which trig ratio do you think would work for me? Opposite and adjacent. Now we are doing maths now. Remember I told you, don't leave your maths. It's 10. So I will then say that tan theta will be what? Fy over what? Fx. Opposite over adjacent. Then I can get my angle. Now we have calculated the magnitude and the direction. Does that make sense? Does that make sense, please? Very important. Very, very important. I want us to stick to the fact that, okay, I saw a thumbs down. Athen Kosi, Divine. Did you guys do trigonometry in grade 10? It means you have forgotten trigonometry. It means you have forgotten trigonometry. Trigonometry, right angle, triangle, opposite, adjacent, and hypotenuse. Let's quickly go through again. So, I have a right angle triangle. Let me see if I can do this. I have a right angle triangle. I want it to be the same shape as what I have here, so that you would see. Remember, this would be on a Cartesian plane. Okay, beautiful. I got what I wanted. Check. Let's go to our trigonometry quickly. This is Fy. Yy. Y is vertical. Fx. And I am looking for that angle. And this is 90 degrees. This is F resultant. It's just basic trigonometry now, right? The side that is opposite the angle is called opposite. The side facing our angle 90 is called the hypotenuse. And the side next to the angle is called what? Adjacent. Now we have opposite, we have adjacent. We look for the trig ratio that connects opposite and adjacent. Opposite and adjacent, tan. Tan theta is opposite over adjacent. Which one is my opposite in this case? Fy. Which one is my adjacent? Fx. And we put that in a calculator. Are we done? Those of you that gave me thumbs down, are you okay? All right. Now, guys, we are going to get to some other questions where it might throw us off in terms of the angle, but I will show you and we would be able to walk through together. Is that okay? I'll show you how to get that angle. Remember, my note says start from the positive and then you walk through. That is why, please, I want to emphasize something. Make sure you draw before you calculate and show the examiner where your angle is. All right? Show the examiner where your angle is. Let's try our first question that we did earlier on. Do you remember the question we did earlier on? Let's try this now. Now let's go complete it and find the angle. Let's find the angle here. Okay, so we have 5, 25, and we have what? The resultant. Is that fine? Okay, so this is what we had. I'm going to draw it on a Cartesian plane quickly so that it helps us. We have a 5. I think our 5 was here. Let me use a green one. We have a 5 there, right? We have our 25 there. And we have this as the resultant. 5 newtons. This is our 25. And we have our F resultant, which we calculated. Make sense? We're looking for that angle. So what do we do? This to this angle, this becomes what? Opposite, and this becomes what? Adjacent. So what do we have? Tan theta equals to what? 25 over 5. Tan theta equals to 5. What is theta? We're not looking for tan theta. We are looking for theta itself. What do we use? Arctan of 5. I hope we all still remember that from grade 10. That's why I said, please bring your maths in. Don't leave maths. Saying you are going for physics. What do? We find shift 10 of 5. And what's your answer? 78,69. And what's the unit? It's in degrees. All right? 78,69 degrees. Is that okay? 78,69. Now, this gives us the direction. What was our resultant force again? Root of 650, I think.
Yes.
Which was what? 25,5. Yeah, it was 25,50. We did this earlier on, right?
Yes.
So, my F resultant would then be written as this. Check how I write mine. All right. Mine force would be 25,50 newtons. Is that okay? Now, our angle 78, what? 69. I like to mention where I am starting from. Is that okay? Where are we starting from? This is the east, right? This is the north. What is this? The west. And what is this? The south. Where are we measuring from? The east. Is that fine? Now, I'll tell you why. Because there are different representations of this angle. But ideally, we should start from here and go anti-clockwise. So I could just say 78,69 degrees. Magnitude and direction. Now, some other will then come this way, which is not wrong. 25,50 newtons. East, 78,69 degrees north. Saying you can start from the east. I am starting from the east and I'm moving towards the north. You would find some other representations like that. Telling us where you are starting from and where you are ending. Starting from the east. Because somebody else could measure that 78,69 from somewhere. All right? Due to different representations and understanding of angles. But usually it starts from the positive x and we move to what? We move anti-clockwise. But I'll show you different questions as we go on and how you should then write your answer. Guys, are we okay with this? Please let me know. Because tomorrow I'm going to go to serious 2 dimensions where we need to learn how to find components of forces. Learners lose it there. So I want to do it when you are fresh. Please, are we okay? Is this making sense to us? A force must have both magnitude and what? Direction. Let me create one question for you now. I want you to find the magnitude and the direction. Please get it right. Just one question. Just one question. Just one question. Let's see. 15 newtons, 8 newtons, 3 newtons. We start from simple ones, guys. I don't want to crush your confidence in physics. 23 newtons. 17 newtons. 18. 16 newtons. Okay, let's see. Yeah. Please calculate the resultant vector. Let's be fast. This is going to be our last question today. And then we continue. Tomorrow we start with how to resolve, how to do other angles. Okay. Tondani, your hand is up. Is 17 the orange one? Yes, it's longer. Can you see it's longer than the green one? So that makes it the 17 one. Thank you, Samantha. Let's give ourselves time. 5 minutes. So we can mark. And then we end the session today. By tomorrow, we must all be okay with how to deal with forces. And I'll do some complex ones as well. Remember, we are also getting the direction. to beat the time? Okay, I see answers. I see that we're getting the same value. All right. Guys, it's important, like I said, the direction is going to cause a bit of worry here and there as we go on, you would see. But we'll try to make sure that everyone is able to write the correct answers. Okay, now quickly, what do we know? I'm going to be very fast since you have answers up as positive. Fy will be what? 15 plus 3 minus 8. Is that what we have? 15 plus 3 is what? 18. 18 minus 8, 10. All right. 10 newtons where? Up. Okay. Horizontally, what do we have? Let's choose right as positive. So what is Fx going to be? 23 minus 17 minus 16. Do we agree?
Yes.
So what's our answer here?
10.
Oh, 10 as well. But negative what? 10. Is that fine? By the time we draw, no matter the direction, your answer, by the time we draw, or let's change this, it must be 10 newtons left. That's why I did the example earlier on using two different directions. So if I draw, what would I have? I have one going where? Up. And I have one going left. If you don't have this, then you are wrong. Please make sure you draw 10 newtons and 10 newtons.
I got it, but I didn't get time to finish.
No, you must finish. In an exam, there's no you got it, but you didn't finish. There's nothing like that. I got it, but I didn't finish. You didn't get it. All right. There we go. So what's our resultant? Our resultant is that way. Make sense, everybody? I hope that diagram is fine. Now, this is going to be our F what? Resultant. Now, let's quickly get our F resultant squared, which will be what? Fx squared plus Fy squared. Are we together, everybody? All right. What are we going to have? 10 squared plus 10 squared. That will be the square root of what? 200. And that will be F resultant will be what? 14,14 newtons. That is the magnitude. Yay, guys. I see a lot of 14,14. Great. We're there. The challenge is going to be our direction now. Is that okay? Now, remember what we said. That this thing should be measured from the positive x-axis. And that should actually be from here to that side. That's how it's supposed to be measured. All right. But now, like I said, we're going to do some complex questions. This side is out of my diagram, right? Which means I can calculate that angle. That is inside my right angle what? Triangle. Does that make sense to you, everybody? All right. So let me draw this out so that you're not confused with what I'm saying. This is what we have. All right. F resultant, 90 degrees, Fy, and Fx. And we are looking at that angle at the moment. That we can quickly get from our trig ratio. Is that fine? All right. So how do we get this theta? Quickly. Tan theta is opposite over what? Adjacent, which is 10 over 10, I think. Beautiful. 10 over 10. And that is what? 1. Tan theta is 1. What is theta? Theta is the arctan of 1. And that is 45 degrees. Now, the question is, how do you put your answer down? Watch this. We said start from the positive x-axis and move where? Anti-clockwise. So if this whole thing is a straight line, check, because we should actually start from here and go this way. Is that fine? Positive x and move anti-clockwise. All right? But I'll show you there are different representations. That's why diagram is very important. So my theta therefore should be what? 135. Does that make sense? If this is 45 degrees and we have an angle on a straight line, 135 degrees. So my answer, I'll show you different representations now. All right, and they are all correct. F resultant will be what? 14,14 newtons. Is that fine? 135 degrees. Somebody who knows physics would know where you are measuring from. That you are measuring from the positive and you are going what? Anti-clockwise. Does that make sense? Somebody else could do this. They would not be wrong, all right? Now, this is my north, my east, my south, and the west. Now I want to use west and north. Do you notice if I start from here and go this way? Where am I starting from? From the west. I am moving towards the north before I go to the east. All right, from the west to the north, 45 what? Degrees. Somebody else can do that. You'll see these different representations. That's what I'm trying to quickly show you. From the west to the north. Somebody can do that. Okay. Why don't we calculate with negative angles? All right, we can. There's nothing wrong. Denzel? There's nothing wrong. All right, we'll see some examples, some complex examples tomorrow. Just we want to find a way that everyone in the world would be able to read the angles. So there are negative angles. When we do tricks, you would see there are negative angles. But ideally, your angle should be measured from the positive x and measured anti-clockwise. That's how we do trigonometry. Measured from the positive x, anti-clockwise. Once you move clockwise, it becomes a negative angle. Okay, so I want to take it step by step because we have not done trigonometry yet to that extent. So I want to take it step by step. Tondani, your hand is up. You want to talk to me quickly? Because I'm done for today. Yes, Tondani.
Good morning, sir.
Good morning.
I'm lost.
Hi. I thought you were Tondani. Now you are lost. When did you change your name? All right, Tondani. Let me assist you. Where are you lost, my child?
So when it comes to the triangle and the 135 degree, so is it like an external angle?
Okay, but are you okay with the resultant force, the magnitude?
Yes.
All right. Okay. So this is what we have. Let me assist you here. Okay, I see a lot of questions as well. Where did we get the 35? That is my Cartesian plane, right? North, south, east, and west. Is that fine, everybody? Tondani, keep your mic on. All right. Where is our resultant? That's our resultant force. Are you there?
Yes, sir.
Okay. Are you okay with this angle?
Yes, sir.
You understand how we got that angle, 45 degrees?
Yes, it's through the 10, right?
Yeah, using the 10. 1045. Are we okay?
Yes, sir.
Good. But we said, conventionally, we should measure from the positive x-axis and measure in which direction? Anti-clockwise. This is the right thing to do. in the world. Where's my positive x? Here. Let's measure anti-clockwise, means we are going left. Does that make sense to you?
Yes.
But we know that this entire angle is what? 180. But I know that part as 45. So how do we get that other angle? We subtract. All right. There's somebody whispering to you there. I can hear. 180 minus 45. And what's your answer? 135.
Thank you, sir.
You're welcome. So you are telling someone to say, okay, measure 135 from the positive, going where? Anti-clockwise, and stop when you reach the 135 degree mark. Guys, are we together now? All right. Like I said, there are different ways of representing this. Okay? So if you are confused, make sure you mention where you are starting from. North, south, east, and west. Where are you starting from? Starting from the west, I'm going. But directions usually, in terms of bearing, we measure anti-clockwise because we are using trigonometry. All right, guys, everybody okay here? Sorry, I missed that thumbs up. Are we okay? Daisy, we okay now? Lovely, lovely. All right, guys, this is what we were able to complete today. Now we know how to walk around. What are we looking at tomorrow? Because I want to excite you to tomorrow. We need to be able to do that. Tomorrow now we are looking at how to resolve. Please don't miss it. Don't miss it. You'll be given a resultant. You now need to find the vertical and the horizontal. Does that make sense? You'll be given what? A resultant. For example, this one here is a resultant. You need to find the vertical and the horizontal. I'll be telling you why you must do that. Is that okay? I'll tell you why you must do that and what is the importance of that. All right, so don't let me jump. I'll start doing that from tomorrow. All right, but so far so good. Everybody good. All right, so tomorrow, same time, same place, same dial, same link. All right, make sure you are early. We start on the dot at 8 and finish. By the time we are done tomorrow, we are done with this. Next week, we start looking at Newton's laws. A very important section in physics. Everything we've done here will be tested in grade 12. Please, so this is very, very important. Anyway, guys, this is where I'll be ending. If you are not on the group, please make sure you find yourself on the group. All right, and from tomorrow I'll be sharing information about how the extra class runs. All right. Do have yourself a lovely, lovely day. If you are not on the group, please send a message to 081. Let me show you that number. Please send a message to 081-744-2103. You should be added to the group immediately. Goodbye, everybody, and enjoy your day. Bye, Kyle. Bye, Kamani. Denzel, bye. Todani, bye. Teboko, bye. So if we have question or lesson for when we revise, we can message you. All right. Kamani, you are on the other WhatsApp group, right? So yes, you can. And we'll talk about all of that as we go on. Goodbye, everybody. Bye, Brinley. Bye, Samantha. All right, goodbye. Thank you for the love.